Hello everyone, welcome back. Bit of an odd video this one because I had planned to do most of this as live streams. I'd hoped to pick up a Quantel Henry on Monday and start doing live streams on it to try and figure out what's wrong with it and try and repair it, etc. So that unfortunately didn't happen because I didn't really receive the machine until Tuesday afternoon. So that sort of delayed things a little bit. And I had also planned to do some live streams on Thursday as well, but I did some preliminary looking into this Henry system that we're going to look at in a minute, and I suspect what would have happened is I would have started the live stream, started to look at the system, and then after maybe 10 minutes I might have realised I can't really go much further. So I opted to suspend doing the live stream because it would have been a bit dull, and just condense it into a offline video like this. So to get you started, a Quantel Henry, what is it? This is a system that was created in the mid-1990s. In a way, it's an evolution of the original Quantel Harry system, which was from the mid-1980s. What the Harry system was the first non-linear compositing system and editor. It was very, very basic back in the 1980s, and it was basically reborn as the Henry, but it used the more modern architecture that Quantel were using at the time, which was called the V series. So the Henry system was Quantel's top of the line system, certainly for video production. They did have other systems. The Henry is basically, it does everything. It does editing, effects, painting, you name it, it does it. So it was their top of the line system, and all of those other systems that were below it were basically had some features from the Henry, some didn't. So things like the edit box was most closely related to the Henry. You could do editing and some effects. Henry has some more features to allow that, to make it a bit easier for doing special effects and stuff. HAL, that was really, really effects based. You could do lots of compositing, and it was really suited for creating a short sequence of effects and things like that, which would have been incorporated into something else. It could do very basic editing, but not to the extent that the Henry or the edit box could. So the Henry is kind of like an edit box and a HAL rolled into one. Now, like all of Quantel's systems, they did evolve and get more powerful as time went on. I have a system here which is a Henry. It's actually a Henry Infinity, which seems to date from about 2001, which is quite surprising because that was when Quantel started to abandon the architecture that they'd been using since the mid-1980s and moved over to Windows-based systems with plug-in cards, whereas the old V series architecture was completely and utterly dedicated hardware. So everything ran on this V series hardware, which is based on the Motorola 68000. So some of the extra features you'd get on the Henry would be things like being able to incorporate the graphics with other 3D packages. So you could do 3D moves within the Henry and then export that out to be loaded into 3D packages like Maya, for example, and you could then render some 3D graphics and then bring those back in and then composite over the video that you'd had manipulated. So you could do some quite sophisticated 3D graphics, compositing and things like that. So there was quite a few more advanced features. It also had the ability to use 5D's Masher, which was a third-party add-on to the edit box and Henry. This was a system which allowed you to create a pack of effects within the edit box or the Henry, and then rather than having the Henry and edit box do all the rendering, it would then send it out to a separate system which would do all the video rendering while you could carry on doing other editing and effects on the actual machine. So that was another advanced feature. There was loads of more integration into things like Avid, with EDLs, which are edit decision lists, which is a list of edits. And as far as I'm aware, the difference between the Henry and the Henry Infinity is the Infinity model allowed you to have infinite effects layers, which is, infinity is quite a big number, so I think that I'm sure there is a limit somewhere. So that's quite interesting. Normally I think it has 8, so that's one of the differences there. So what we'll do, I'll show you the system, and then I'll power it up and show you what it's not. I'll show you how it isn't working. So I've got the system here. It's actually tipped on its side at the moment, so just gives me access to the cards. So you can see here it's a rather large unit. It's bigger than the HAL by a little bit. Basically, the HAL is the same size, but it just doesn't have this section on the bottom here. You can see here that there's some hard disks installed in the base. So yeah, normally this would be flipped 90 degrees counterclockwise, so the top is up here. On the front we got MO drive, just like many other Quantel systems, and we have all the cards then slotted into the side. I was going to say the top then. So if I switch over to the other camera, I'm just going to tilt this forward and I will show you what's in the top. So yeah, you can see here it's very, very similar to the HAL system. We've got a big power supply. This is an Aztec 800 watt power supply with some rather beefy wires going on there. In the top we have the system disks. So we have a disk which runs the shared networking side of things. Underneath that is the main system disk, and then this disk here is the audio disk. So audio is recorded separately onto that drive. Just at my hand here we have the MO drive poking through, and right over this part here is all the SDI inputs and outputs. Yeah, just like the HAL, they started to separate out the actual input and output modules from the main card and put it onto this this backplane bit here. Now, as far as I can tell with the cards that are in this system, it does appear to be pretty much identical to a Quantel edit box. So I think this might be another one of Quantel's little tricks, as in it's just a software option to enable all the extra features that you get on the Henry over the edit box. So yeah, it's quite surprising that. I'd had expected at least some differences, but it does appear to be yeah, identical to an edit box. In fact, it's very hard to tell the difference between the two without actually powering it up. So like the HAL, which is slightly smaller than this, we've got 2 CPU cards. The HAL actually only has 1. The edit box has 2. As far as I'm aware, the first CPU card boots the main operating system, so that's here. So just a standard CPU 42 card with a 68040 processor on it and 64 megabytes of RAM. The second CPU card, I believe, is running the ClipNet stuff, which is all the access and interfacing out to the disk arrays. This did surprise me somewhat. I thought this was being used for something else, but from what I can see in the user manual and some documentation I've seen on trying to figure out faults, is this card does all the video storage interfacing-y stuff. So that is quite interesting. The next card down is the network card, which I can remove. That's an earth connection, and we have the actual Ethernet out. So this card is a completely separate 68,000 based system. It's got 16 megabytes of RAM on here, and that runs a special version of Quantel software which enables all of the TCP/IP networking. Now, most of that is actually based over FTP, and it's sort of Quantel's own implementation of FTP. It's completely compatible with everything else. It just has extra options to do various special things. So you can convert TIFF files into Quantel's own format when you actually do the FTP transfer to or from the machine. So, which is quite a nice feature actually. So that is quite a powerful board. Next card is the input selection card. So this switches all the different inputs to actually enable recording and all that sort of stuff. So we've underneath there will be two analog video inputs, and the rest of this will interface up with the SDI, which is on the top of the machine. Next card is called Rave. This, I believe, is a more up-to-date version of the image card which I have in my paint box, and that is in turn an updated version of the cap and size and rotation cards which you get in the regular paint box. Now, Quantel don't normally do abbreviations for their cards. They normally have very plain names, but this one's called Rave. I do wonder whether it's a real-time audio-video engine. It's a possibility. There's a couple of 56002 DSPs on there and a load of FPGAs, so I wonder whether this is doing audio and video possibly at the same time. Next card is one that's very familiar to anybody who's seen inside a paint box. This is a perspective card, and basically just does perspective transforms on bitmaps. So yeah, it's a very common board. This design has been around, or Quantel were using this design since the mid 1980s, so that's certainly doing well. The next card, very classic card, although this one is slightly upgraded. This is the disk store card. So this on all of the Quantel Express models is a 24 megabyte model. The normal disk store card is normally 12, so double the RAM on that. Probably to allow it to have larger numbers of cutouts that you can manipulate at the same time. So you obviously need more RAM to do that. And Quantel main store card, slightly updated, but completely compatible with all of the main store cards which have been in Quantel systems since the 1980s. So yeah, very, very standard card. Output selection card. So like the input one, this handles, we've got 2 channels of analog video, and the rest is all digital interfacing up to those SDI outputs at the top. So yeah, just a video output card. Now this card, you only see it on the edit box and the Henry. It's called Display Store, which is unusual because normally the Display Store is the main store card on a paint box, and the video is sort of clocked out of that on its own. But this seems to be a separate store card, so I wonder whether they've got some extra buffering going on in between the main store card and the actual video output, and it actually all gets transferred into here, and then this is what goes to the output. So an extra layer seems to have been added in there. And this one is called Key 2, so I think this is a dedicated card just for doing video keying, or keying one layer over the top of another. So there's obviously a fair bit of stuff going on there. Got custom Quantel chips and lots of logic ICs for doing sort of basic math operations and things like that. So, and obviously there's a load of custom program stuff on there as well. This one is called VidProc 2, Video Process 2. Not entirely sure what it does, but there's obviously a fair bit on there, so it's probably doing quite a lot. So it's a shame I can't really get a block diagram of the Henry to actually figure out what all of these blocks actually do. Next card is Filter SM. SM normally means surface mount, so this is just a non-through-hole version of the card. Filtering is normally the bilinear filtering that you do when you're scaling bitmaps and things like that. So they've got a separate card dedicated just for doing that. This is a size card, slightly different to the one you'd find on a paint box, because there seems to be 3 channels. So I think what they're doing here is they've just multiplied out the video processing, times it by 3, means it can probably do the YUV processing in parallel to achieve a higher speed, do all that rendering quicker. Another big complicated board, this one. It's called Address 2. There's a lot going on here. We've got some extra RAM, we've got loads of CPLDs, and there is actually a Analog Devices Shark DSP on there as well. So this is obviously doing quite a bit. I'm not entirely sure what it does. It might be something to do with linking the video files that get composited to the actual disk store, so that might be doing some address translation for the videos. Speaking of the disk store, we have this card called Disk Interface. So it's not fully populated, so there's obviously some more to go on here, but that's obviously something to do with the disk interfacing. Exactly what, I'm not entirely sure. Again, without a block diagram about how this system actually works, it's very, very hard to tell. So this card is actually double-sided. We've got stuff on both sides, and it's called ClipNet. So this is the ClipNet interface. This uses fibre optic. There's actually the fibre optic connections down in there. So yeah, this is the high speed link to the disk arrays. Obviously a load of FPGAs going on there, and some RAM. But yeah, again, it's not fully populated, so I'm not sure what else that would have been used for. And this final card is called Disk Controller M2. I think this is the interface to the disks that are actually installed in the system here, rather than the ClipNet. So Yeah, you've got a load of FPGAs going on there, EPF 10Ks, so they wouldn't have been cheap back then. Obviously, we've got blocks of 3 going on here, so there's obviously something going on in parallel, and we have 6 SCSI controllers on the end there to go out to the 6 drives which are in the base. And the drives, these just simply come out. They are heavy because they are full height 3.5-inch discs. So these discs, obviously they're not the normal profile, they're slightly larger. These are all 36 gigabyte 10,000 RPM drives, which back then they wouldn't have been cheap at all. So those have just been mounted on a PCB with some big aluminium plates on the back to keep the strength up. So connectors on the end. So there's another bank of these on the other side, just down in there. Right, so we've had a quick look at the system there. I'm just going to flip over to my PC and we'll power it up and I'll show you what it actually does. Okay, what I've got here is my diagnostics cable plugged into the Netcom board. I have the CPU 1 and CPU 2 cards disabled at the moment, so I'm just going to power this on and we can watch the Netcom boot up, and I'll just quickly show you that and then we'll switch over to the main CPU cards. So I'm just going to power this on. So once the shared drive spins up, it'll start to boot, which it's doing. So that's it booted up. So we now have the FTP server running, and that has access to the shared drive, which you can just see in here if I do flist 10. So those are all the files that are on the shared disk. So that side of it is all working. It seems to be working just fine. So don't need to see all of those. Obviously, all of these files here would have been shared with other Quantel systems on the network, and this would have been the mechanism to get pictures and files between the Henry and other systems like Avid and Macintosh for pictures and all that sort of stuff. So I'll just stop that. Oh, it's just finished anyway. Right, so what I'll do now, I'll power it down and switch over to the CPU 1 card, and I'll show you what it's doing there. Right, so we're switched over, so I'm just going to power it back on. I've set these cards to not auto boot at the moment, so it just makes it simpler. So it's just booted into the bootstrap and it's just waiting for input. So I'll just let the disk spin up and then we'll see if we can access it. And what I'll do, I'll manually load in the Henry software and then boot it. So there we go, it's up and running. So normally the CPU 1 card would boot the first item, which is boot 1, that's called Henry 1, and then the other CPU card loads in Henry 2. They are almost identical files, just a few slight differences. There's a few K different in the file size, so I'm not sure how Quantel have these two systems, the two CPU cards, integrate with each other. I'm not quite sure what mechanism they use to do that, but there we go. So I'll just load in the boot file. It's a little bit quicker on these cards because these are the 68040 based boards and are a little bit quicker. I should say that both CPU cards access disk this main system disk together. So it's there's basically two hosts accessing this drive. So when this actually boots up in auto mode, both CPU cards are trying to read their own individual files, so the loading time actually halves. So once that's loaded in, we can boot the actual software. And from here, normally if it was set to auto boot, it would then run the actual main user interface software, which is called the DPB. So if I try running that, it'll just run up and then it'll just eventually stop. Now why it's actually stopping, I have no idea, and I'm not really quite sure how to get further, to be honest. And this was going to be my problem when I was doing the live stream. I suspect if I hadn't have checked first, I would have ended up getting this far, and I don't think I would have been able to get much further. So it will basically just hang and just do this now for forever. We'll stop that there and switch over to the CPU2 card. So we're now switched over, and I will do the same for the CPU2, and what we'll do after this, I'll actually put it into full auto boot mode. So basically how it should be when it's working properly. It does behave slightly differently then, probably because the two CPU cards are booting up at the same time. They probably expect that. So 2L. Looks like that's about as far as that's going to go. So what I'm going to do now is just put this into full auto boot mode, and we'll see where we get. So CPU1 card needs to be set to ID 1, and then CPU2 goes to 2. So I will power back on. So we're still connected to the CPU2 card. As you can see, the boot loading time is a lot slower now. Both of those CPU cards are trying to access the same disk. So, and the netcom board should boot up in just a moment, because that's completely independent. You'll see here, once that starts to go to 1, and then it'll start counting round as like a heartbeat thing. So netcom is running. Yeah, you can see there the CPU2 is going a little bit further this time. I think that, oh no, just going a little bit further. That is where we get to on this. So the Syslink 2, I think this is part of the mechanism where the two CPU cards talk to each other. We've got ClipNet and Programming Saint and Programming PCI Cont, not sure what that is. And then we just have these final ARM POKE 64, and that's it. That card does no more. I believe it should come up with menus to administer all the ClipNet and the shared drive, the DIL and disk arrays, but that doesn't happen. It just doesn't do anything. So what I'll do now is I'll power this off again and switch back to CPU 1 so we can see what auto boot looks like on CPU 1. So this will boot up in a more familiar fashion to what we'd normally see on a paint box. So that's as far as it goes. Normally when it auto boots, it would then run the DPB software and the system would come up. But there's obviously something in this initial part of the boot procedure which is meaning it's not going to try booting up properly. So obviously there is a device not found, so maybe that's something to do with the not having the DL disk arrays attached. It's possible. So I'm not really sure what the issue is. There could be a hardware fault. It could be that I just don't have the DL disk arrays for it. It's one of these things where you're not quite sure whether it's you've got a faulty system or you're just missing parts. So it's a very, very difficult problem to try and figure out, especially on a system like this, which is so complicated. So what I'll try doing now is just force starting the DPB software, which does get a little bit further, but not by a lot, to be fair. That last command there, J clip sit up. A lot of the edit box and Henry systems use Java, so that could be Java clip clipnet setup. Again, because we don't have those drives attached, that's possibly why it's hanging at that point there. It's just expecting to find something that isn't there. So this should, after a bit of time, carry on, and we'll start seeing a little bit more. It does take a while, if I remember right. Obviously something's probably timing out after a period. There we go. So it's got the shared disks, we've got the Java stuff loading, we've got the filters, a lot of this stuff you see on the normal paint box, and then finally we have this booting QVM application and waiting for application, and nothing happens now. That's it. So that's about as far as it goes, and I have no idea how to try and diagnose this problem. Obviously an engineer from back in the day would have looked at that and gone, oh, I know exactly where to start looking for that, or yeah, you need to plug on the disk drives, you idiot, you can't run it without them, that kind of thing. So it's just hard to make any more progress, really. I think that's why when I realised it was only going this far, and there doesn't seem to be any avenue to take to get any further, I thought the live stream thing might have been a bit of a non-event, which is why I condensed it down into this video. Now this system isn't mine, it's going to go back to its owner with a little report from me about what it's actually doing, and maybe at some point we'll pick up a disk array for it and maybe that'll bring it to life, who knows. So if that ever happens, then sure, I'll do an up-to-date video and bring you up to speed if we can actually get it working. Okay, sorry I couldn't really show you much more of this actually working, because it would have been quite an impressive system to look at, but there we are. Sometimes these things just don't work out. So thanks for watching, everybody, and I'll see you on the next video. Bye for now.